Okay, now let's try graphing this. First we start with the parent points. So the parent points on these always start at 0, 1, 1 and the base. So in this case the number that has the base, or the number that has the exponent here, is 1/2. And then we always use the asymptote of y equals 0. So what we're going to do, instead of how we did in example 1, we're going to take a look at the numbers and what operation that they're doing to the graph. Because unfortunately these are not near as easy as the graphs that we did with the function dance, where all you had to do is find the starting point and then graph your slope. So what you need to do anytime, if you see this is multiplying by a 2 and adding a 3, if you remember your order of operations, you have to multiply first. When you multiply, you're always going to multiply to the y. So you multiply each of these by 2, and we get the coordinates of 0, 2, 1, 1, because 2 times 1/2, and then 2 times 0 is always going to be 0. Now you need to remember this plus 3 on the outside is our up and down. So up and down always affects the y. So we're going to add that 3 to the y. So it gives us now the coordinates of 0, 5, 1, 4, and then an asymptote of y equals 3. Now what this does is that gives me the ending coordinates of after all these movements. So if I graph 0, 5, 1, 4, and then my y-intercept at 3, then connect my dots, and then that's my graph. So what we need to do now is talk about domain and range. If you remember, domain is your left and right. So if you look at this, we do have arrows that point to the left and to the right, so your domain is all real numbers. Your range is your up and down. We do have an arrow that points up, but the other arrow kind of ends up going horizontally. So it cannot go past that asymptote ever. So we're going to have y, since it points up, is going to be greater than, and then my asymptote is at 3. If you notice, your range is going to be whatever your asymptote is. Please notice I don't have a greater than or equal to like the other graphs, because it's never actually going to reach that 3. It's just going to get very close to it. So that's your domain and range. Let's try this one more time. We have a new equation. Again, start off the same way. Figure out your parent points. The parent points we start with always 0, 1, 1, and the base. So in this case, the exponent is on the 3, so 3 is your base number, and then y equals 0. So you're always going to be starting with those 3 things. Now we look at the other numbers we have. We're multiplying by negative 0.25. We have a plus 1 up in the exponent and a minus 4. Let's start with the multiplying because that comes first in your order of operations. Again, that will always multiply to the y. So I'm going to multiply each and every one of these by 0.25. So this coordinate now turns into 0, negative 0.25. And then 1 and 0, negative 0.75. And then asymptote stays as y equals 0. Now, if we look at the number up here with the x, please notice it is adding directly to the x, but that was our understood parentheses, so instead of adding a 1, we have to subtract a 1. That's going to affect all your x's. Because that is not an x, we don't subtract 1. The minus 4 affects your y, so we're going to subtract 4 from each of these, and that does include the asymptote because it is a y. So when I subtract the 1 and subtract the 4, that gets me negative 1, negative 4.25, and that would be 0, negative 4.75, and the asymptote at y equals negative 4. So we're going to graph negative 1, negative 4.25, and 0, negative 4.75, and then our asymptote at y equals negative 4. If you notice in this case, my dots are under the asymptote, so we're going to connect it, and it's now going to point down, and it always follows along the asymptote but never ever crosses the asymptote. Domain and range. Again, the graph points left and right, so your domain is all real numbers. Your range, as I told you before, will be your asymptote, but we need to look, since this points down, instead of a greater than -4, it's going to be y is less than -4. And that's your domain and range. The last thing we want to look at is an application problem. We have a cup of green tea contains 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of the caffeine from their system per hour. Write a function that represents this situation. So this formula is very similar to the one we did earlier with our compound interest. R still stands for rate. So in this case, our rate is 12.5%. But remember, we need to change that to a decimal, so it would be 0.125. And our A, as always, is our starting number. So our starting number here is 35. So when we plug it in, it just turns into y equals 35 times 1 minus 0.125 to the t power. Now we can go ahead and do 1 minus 0.25. 0.125. So it ends up being y equals 35 times 0.875 to the t power. And that's the answer that they want.